Okay, on 25 and 26, you're just asked to find the value of x. And so that requires you to remember some of the theorems that we've learned recently. So one of those says that if you have a diameter that is perpendicular to a chord, now you won't always have the whole diameter. Remember, you might just have part of it, which is a radius. So if you have the diameter or a radius that's perpendicular to a chord, don't forget it also bisects the chord, which means it cuts it into two congruent parts. The vice versa of that statement is also true. So if you have a diameter or a radius that's bisecting a chord, then it has to be perpendicular to the chord as well. Another thing to remember is that all radii of the same circle are congruent. And you might want to look and see if you can form a right triangle on these using that perpendicular relationship so that you can use the Pythagorean theorem to find a missing side. So on the first problem here, I'm given a diameter length of 31.8, so I can find the radius length by simply taking that 31.8 and dividing by 2. So I know all radii of this circle have a length of 15.9. So what you need to notice is that this segment right here, from the center to this point here, is another radius. So it is 15.9. So in this particular problem, I don't need to use the Pythagorean theorem to find the value of x. It's part of the radius. I'm given one part of the radius to be 7. So to find the other part, all I have to do is take the whole radius, 15.9, and subtract the part that I'm given, that's 7. And so my x value is simply 8.9. No Pythagorean theorem is necessary on problem number 25. You didn't even need the 14.3 for the part of the chord for that particular problem. On number 26, you're given the radius to be 18.9. So again, this radius would be 18.9, but that's not really helpful in this particular problem. So you're given this radius being perpendicular to the chord here. So I know it's bisecting the chord. So if this is 15.7, this is 15.7. Really doesn't matter in this particular problem. I need to set up a right triangle, and it really doesn't matter which one of these that I use, either this side or this side. It's the same right triangle. They're congruent. So if I make my right triangle right here, I did that by drawing another radius from the center to a point on the circle. So just like this radius would have a length of 18.9. I'm given this leg of the right triangle to be 15.7. If I know this part, the leg of that right triangle, and I'll call it y, I don't want to call it x since I already have x in another part of the problem. If I find y using the Pythagorean theorem from this right triangle, then I can find my x because I know the whole radius is 18.9. So all I'd have to do is subtract out the part that we get with y, and that gives me my x here. So this is the right triangle that I'm going to focus on using Pythagorean theorem. So we know it's leg squared, so the leg here is y, so we'd have y squared, plus the other leg squared, which is the 15.7, so leg squared, equals the hypotenuse, which is the radius, 18.9 squared. So when we square the 15.7, we get y squared plus 246.49 equals the 18.9 squared, which is 357.21. So subtracting the 246.49 from both sides gives me y squared equals 110.72. So we know to undo the squaring, we take the square root. So we would take the square root of both sides. So when I do that, I'll show you on my calculator here. When I take the square root, I'll just do square root of my answer, 110.72. I get a decimal that doesn't repeat and it doesn't terminate. And so be very careful always rounding before your final answer. It really wouldn't matter in this point, but if you didn't want to round at this point, you could write that your y is approximately 10.522, so on. But remember, that's not your answer. Your answer is to find x. And so the y and the x added together is one of my radii of the circle. So it has a total length of 18.9. So if I want to find x, all I have to do is subtract y from that whole length. So I can do that on my calculator without rounding that value of y by simply putting in 18.9 and subtracting and putting second and then the negative key down here that has a and s above it brings that answer down. So 18.9 minus that answer without rounding it. Then my final answer, I can follow the rounding rules, which said round to the nearest tenth. So in the tenths position I have a 3, next door is a 7, that's 5 or bigger, so the 3 becomes a 4. So my x I found by taking the radius 18.9 and subtracting my y value from it. And we got it approximately to be 8.4. So always look to see if you can use a right triangle, but be careful, you might not need a right triangle. It might be as easy as a problem like this.